wire. Suppose this is a straight wire having certain length, so it's the required point is P. Okay, the current along this wire is carrying from M to N, that is I current carrying through the wire from end M to end N. In this case, if we suppose need to know the magnetic field at the point P, right, then what I can do, we need to integrate the result of that dB expression at P due to all such possible current element along the conductor. Suppose the current element of length dl, so this was the radius vector, yes or no? This was angle theta. So magnetic field at this point we got it as dB due to one element. So integrating all possible values of dB against all elements, right? Integrating the possible values of dB at the point P against each and every current element from end M to end N, the total sum of all possible dB values will be the total magnetic field at P. So that magnetic field at P, which is obtained by integrating dB at P, and that formula what we get finally is mu naught I by 4 pi into A, provided this is the distance A, right, shortest distance, that into sine alpha plus sine beta is the one of the expression to get magnetic field where geometrically alpha will be this whole angle and beta will be this angle. Are you getting me or not? So alpha and beta will be the angles at the required point by each part of the, on either side of the straight portion from the foot of perpendicular. If I drop a foot of perpendicular from the required point on the wire, then that foot of perpendicular will divide the wire in two segments. So alpha and beta are the angles obtained by those two segments at the required point, isn't it? Similarly, the variation of this general angle theta, in one way it will be theta 1, and in another way, because it is to be, theta is always taken from current element to radius vector, as because the current element is current in this way. So at the last element is concerned, for the last element, current has to be considered going upward, and this will be the direction of radius vector. So this will be the last angle of theta as theta 2. If we see the change of this general angle theta formed by one of the elements here with the radius vector, so if that angle theta is appearing between current element and radius vector, so that range will vary from theta 1 to theta 2. So based on theta 1, theta 2, this formula will become mu naught I by 4 pi A. This answer can also be written as cos theta 1 minus cos theta 2. Finally, we can use this supplementary angle. If we use this supplementary angle, the interior angle at the other end, assuming it to be theta 2 dash, then in terms of theta 2 dash, this formula will become mu naught I by 4 pi A. It will be cos theta 1 plus cos theta 2 dash.